Okay, so obviously we're going to be talking about Web3, which is really relating directly to blockchain. We're going to talk about cybersecurity in blockchain and Web3 with the inclusion of cryptocurrency in there too. But the focus is going to be on a little bit on the blockchain side of what are the problems that blockchain faces in security. And then we're going to focus a lot about on the end user side, the consumer side, so to speak. You as the recipient of blockchain now and in the future, what are the security problems that you're going to have, your users are going to have, people in general across the world are going to have. And I like to say, these aren't your dad's phishing attacks because things are advancing quite a bit further than they used to. So I already spoke a little bit about me, so I won't go too far into it, but I co-founded Apozy. I recently co-founded a stealth blockchain cybersecurity startup alongside Apozy, and I'm also the co-founder of RADwood. So Apozy creates a browser endpoint detection and response platform. We collect data from the browser and protect against threats in real time, basically just through a browser extension. So you have the ability to gather information that normally would be invisible without something like an SSL inspection proxy, as well as block threats in real time using native browser isolation, something that we've coined. Without focusing too much on that, if you're curious about what RADwood is actually an 80s and 90s focused car show that travels the world. So we go from here all the way to London and everything in between, and we focus our shows around the culture there too. So the way people dress, the music, the DJs, BMX, etc. This is absolutely not a car crowd, but if anyone wants to talk to me about cars later on, feel free. As I mentioned, I've been in cybersecurity professionally for over 10 years, and I like to say over 10 because if I put the real number, I feel very old. And I've been doing startups here and forth, whether it be my own or helping others. I'm also a Y Combinator graduate, and I've been doing all of that since 2013, so I'm pretty deeply involved. And then obviously Q&A at the end, but if anyone wants to chat with me, forgets what they want to say, wants to tell me I'm wrong, rick@apozy.com, you can get a hold of me, no problem. So it makes the most sense to sort of start with the progression of Web 1 to Web 3, what we're kind of entering now, and that will sort of preface everything we're going to talk about. So essentially, somebody got muted there. Web 1 was essentially the original web. It was ISP run static pages with limited advertisement, limited dynamic content, and realistically, it was sort of more like a research library course, and that's sort of where the web began. I'm sure you all know that. We quickly transitioned to Web 2, which it is an opinion, but pretty much is where the web is now. So it's a social web. It has servers you would expect. It also has a lot of cloud. It has companies that provide services in exchange for something, usually money or data. And that's important to note because if you've heard before, if you're not paying for a product, you are the product. And that's a pretty good example of what Web 2 is right now. You're not in control of your own data. Your data is probably being sold. And for the most part, it's a semi-decentralized, but we all know the cloud is really just a server farm. And that's sort of where the internet lives in its current state. So Web3, which we're going to talk about today, it's the future. We're coming into it now. I say coming soon, but realistically, we've already started to tiptoe into that. And it's going to happen, just to be clear, as a slow transition, not as a dive head first. Just like cloud services and cloud servers were a slow transition, Web3 and decentralization is going to be a slow transition. And it is precisely that. It's a decentralized internet with a focus on privacy, transparency, and free use of the web without the personal data monetization. So it includes AI, it has pieces of the semantic web built in, and privacy. And realistically, the way I like to think about it is that you're the owner of your data in Web3 and not some service that may be using it for another purpose. But really focusing on the decentralized web and how blockchain fits into that is what Web3 is. And I won't focus on this too much. I'm sure everyone has heard this a million times, but I like to share just in case someone hasn't, seen exactly, okay, blockchain, what is it? So I like to go with the quote instead of the definition. I like this quote a lot. Picture a spreadsheet that's duplicated thousands of times across a network of computers. Then imagine the network is designed to regularly update and you have a basic understanding of blockchain. So essentially that spreadsheet across all the machines, and then when someone makes a change, everyone else who is hosting a piece of that spreadsheet has to agree that that is in fact what the change should look like, and then they record that change to a ledger. So it's a digital ledger of transactions that's duplicated across all those machines. So moving quickly away from what all of that is into more of our topic at hand, does blockchain inherently improve security? And the general consensus is it does, in fact. Secure storage inherently with encryption that's verified by all and agreed upon. It's correct and untainted, immutable. It can't be changed without that consensus I mentioned. And if the change does occur, it is recorded. So in that sense, which you can probably already see some caveats and problems there, we'll talk about them in a bit. But the idea here is that everything is encrypted, everything is stored securely, and it's in a place where it can't really be muted or changed or corrupted in any way without everyone knowing, or at least being able to dig in and know that that did in fact happen. It's redundant and it's everywhere. So it's really a good fit for a data security model as a whole. The next step here is a lot of people ask questions about blockchain if you're not familiar about it being public. It feels very public. Everything I do is public, right? So in the same way that PGP works, blockchain works. It really only can access what I or whoever the user is allows you to access and allows you to be seen. That being said, the record of it is available to everyone. So the verification or the record of the transaction or the record of the addition of something being added or changed to the blockchain is there for everyone to look up, but it may not necessarily allow you complete access to what's going on within that block, depending on the application, the blockchain you're talking about. It can vary based on platform and use, but I did want to mention that when people discuss this, they do often think, all right, so it's all public, right? So how can it maintain safety and privacy? And I have a lot of that we'll discuss at the very end of the conversation where I think things need to be moving. Nothing's perfect though, right? So quick sort of hit list of the things that go wrong when you're talking about blockchain or talking about blockchain implementation or what could not necessarily be completely secure or just is difficult. It's slower than traditional servers or even the cloud. Transaction times currently, depending on which blockchain you're talking about, are a bit slower than those. It's pretty difficult to scale at this time. The immutable data has problems. You can imagine if something illegal ends up on the blockchain, whether that be an image or a piece of information or something that is, nation state type attack and the information is public that shouldn't be, that's going to remain there no matter what. It can be removed, it can be changed, but the record's still going to exist. And the record of that information is still going to be there somewhere, especially if it was public in the first place. So it's kind of tough when it comes to things that probably shouldn't exist there, but kind of will remain. It's inefficient at times, both from a power consumption perspective, but also from the processing power that it takes, and again, the time. Interoperability is low, so there's not a lot of integration with existing legacy platforms, and not a lot of ability to say, hey, I have an existing system and I want to integrate it quickly and easily with blockchain. It's not really going to happen. And then lastly, which is hopefully what we can try to work towards fixing and what I'll talk about a little bit today, is there's few security tools to help the crypto community. And that's not just people who are doing cryptocurrency, but also applications on the blockchain, applications being built into blockchain. But we will focus on end users a lot today and people who consume that data or use that data, whether it be a crypto exchange or otherwise. Pardon me. So who actually cares about this? The purpose of this slide is actually to show you that this is being adopted in major institutions, whether we like it or not. JP Morgan has already developed their own enterprise-focused version of Ethereum, and Goldman Sachs is one of the leading investors in USDC, which is a stable coin, meaning it's a cryptocurrency that's tied directly to the value of the US dollar. And this is just a very short list of lots of companies that have a Web3 arm or are starting to think about Web3 or blockchain and how that moves forward. I've actually been reached out to by a number of telecom companies that are actually looking already at doing Web3 and building out their Web3 arm and getting in touch with me about sort of my thoughts on it and things in that area. So this slide is meant to be a little funny, and we're definitely not going to jump into this. But as you know now, the threats that exist on the web have a million different solutions, a million different ways to sort of chop away at the same security onion that we're all building and we're all familiar with to stop phishing, to stop malware, to stop intrusion, to do intrusion detection, APT, everything you can imagine has a something to protect against it. But this list, when it comes to blockchain, is extremely, extremely short. I actually think that this whole thing that we're looking at here is, personal opinion, think it's still a little bit broken, but not the topic for today. That's a thing to email me and yell at me about. So we're going to talk about the new threats that are coming to blockchain. And again, the users of blockchain, whether that be people who are doing cryptocurrency related things, people that are creating applications on the blockchain, or simply using it in general. A lot of these names here that you see here are going to be, all right, I know what spear phishing is. I know what ransomware is. I know what scams are. But they've changed, they've adapted, things look a little different, they're a lot more difficult to catch. And more importantly, when you talk about social engineering, you're going to see people even more confused than they've ever been. Spear phishing, the first topic at hand here. Cryptocurrency phishing is just like old school phishing, but more sophisticated. There's a lot more at stake for people, especially if they're a little wary or unsophisticated with what they're actually trying to do in the blockchain or in cryptocurrency. Something well crafted and properly targeted is going to succeed. So the example I have on here is actually a very well crafted Coinbase email that I originally, this is not my copy of it, but I originally saw a copy of this pretty far back, and it was a one-to-one replica of a Coinbase password reset email with all of the links perfect. And by perfect, I mean they actually went to Coinbase except for one. Of course, the one that's going to be the most dangerous, as the word we'll use, the one to reset your password actually went to an owned device somewhere. And this was a scam that went around, a spear phishing attack that went around to a lot of different Coinbase users. So the point here isn't that spear phishing is new and you guys don't know what this is. The point here is that with this new landscape of cryptocurrency and blockchain, people are already a little confused if they're not technically savvy. So it's really, really, really easy to convince them of something, especially if they're not already familiar with it. So you've done your security awareness training, you've done your phishing training, but you haven't prepared people for something where they're not even exactly sure what they're supposed to be doing in the first place. And despite the fact that our warning should be, hey, if you're not familiar with crypto or blockchain, don't do it, that's not going to happen. That leads me actually into the next phase here that really helps people out in doing things that are tricky is unstoppable domains. So they're really, really easily put. It takes a wallet address, which is a long string of characters you can see here, not readable, not usable, looks strange, and turns it into something that's human readable. That address is actually real. rickdeacon.crypto is my unstoppable domain. So when you create an unstoppable domain that looks legitimate, and you're asking someone to send a certain, say, cryptocurrency to that domain, you're setting them up for failure because of the fact that it looks so realistic. Coinbase.crypto, Binance.crypto, Binance1.crypto, ReceiveBinance.crypto, whatever it may be, all of these domains are really convincing. And I'll mention the other thing about them is taking them down isn't as simple as contacting a registrar. It's not as easy as telling Google, hey, this domain is hosting malware and hosting a phishing campaign, and there's a toolkit XYZ installed on it. These domains are on the blockchain. And as we've already learned, and as you already know, they're immutable. The domains can't simply be taken down. So once they're up, they're sort of up unless you use other mitigating factors to sort of stop them. So this is the elephant in the room. Everyone heard about this in the past couple of weeks, the Colonial Pipeline attack caused by ransomware, and then, the failure of the Colonial Pipeline caused by ransomware. Furthermore, the FBI raided some of the servers and devices that were hosting a lot of ransomware collected cryptocurrency, and it's a really big problem. And the reason why it's a really big problem isn't just because ransomware is evolving purely for the purpose of getting cryptocurrency, especially as it goes up in value and people are more familiar with it and spending it on unlocking your machines doesn't really seem like that bad of an idea at the moment because we need to get back to business. And what's $50,000 worth of Bitcoin? The problem is actually the amount that comes from ransomware. In some senses, cryptocurrency is propped up by the proceeds from ransomware. The speculation that occurs, the people trading it back and forth, I'm guilty of it, not of the ransomware part, of course, of the trading back and forth. A lot of the price is inflated because how much is coming from ransomware attacks and how much of it is being traded from essentially illegally obtained methods. So at some point, we as a security community need to help, especially as Web3 comes about further, we need to help sort of separate art from artist in the sense of cryptocurrency in and of itself is not bad, but its ties to ransomware are difficult to sort of separate and not talk about both at the same time. So the purpose of this slide is not only to inform about that, but also to sort of think about the concept of, ransomware is evolving because cryptocurrency is becoming more and more important. And as things move to blockchain and Web3, all the applications that are being used are token-based and token incentivized. So it's going to get worse. Which leads me to crypto scams. We won't talk a whole lot here because a lot of them are pretty straightforward, but it's the promise of quick money from things like new exchanges and new coins. Pump and dumps, for example, where a bunch of people on Twitter, a bunch of people on Discord are talking highly about this brand new coin, this particular coin that's coming online, and you can make a ton of money by doing it. And then they drive the value up, everyone buys it, and then the original people who created it just dump it all, and they made all their money, leaving everyone else with a bunch of it. Of course, not necessarily a cybersecurity problem, but it brings these scams to light and brings these things that need to be taken care of for the end user to prevent problems, as with anything, as with any sort of financial scamming or financial fraud. There's also attacks related to bots, that bots are meant to purchase and buy coins at a very particular time based on when a pump group says it's going to pump. And then, of course, what they do is prime it themselves by buying just a few seconds before that pump actually happens. And then another thing we'll talk about here is, pardon my language here, but these coins are literally called shit coins. It's called it's poo coin charts. It's hilarious and ridiculous. And the reason why I bring this up and show you this slide and show you this picture is because all of our cybersecurity career has been basically around telling people to look for legitimacy. Check the email, check the sender, check the from address, check the domain, check what's going on. Does it seem like it's written well in good English? If it doesn't, well, it's probably just a scammer. When you're talking about cryptocurrency and blockchain, you're talking about things like this that are inherently strange. They're weird. I mean, look at this website. It's a legitimate website that's trafficked by millions of people every day to look up the value of low market cap tokens, but it's completely legitimate. There's nothing nefarious or bad about it. It's just ridiculous. So when you're talking about that, it goes against everything that in a situation where everyone has been taught to look for legitimacy and legitimize everything that they're looking at before they take action. The landscape is changing a little bit. Younger people are coming into the workforce. They're used to things like that. It's easier to confuse them. Social engineering and scams is easier to do when things are so convoluted with what looks like nonsense in some senses. And then the last thing we'll talk about here in these new threats is the bait and switch. So it's the idea of a legit application, let's say a cryptocurrency wallet or a blockchain application that does mortgages or lending or something like that. It's created and distributed and then later turned into a theft tool, either at the supply chain level from a hacker or an attacker, or from the people who actually created it. Usually that's actually very few and far between. There's not too many people who go through that entire process and then flip the script on everyone. But it is pretty simple for a blockchain application to not have security built in from the beginning, classic tale of application security, and then someone comes in at the supply chain level, switches the application to be nefarious, and is immediately just draining everyone of whatever it is that application is using, whether it be information about them or whether it be cryptocurrency itself, something along those lines. So that's the consumer side of things. That's what we and our users and friends and family need to worry about. Let's talk a little bit about what actually happens to the blockchain itself and what attacks look like on the blockchain when you're talking about what's being built, how it's being built, how it's being controlled. So we're going to talk about 51% attack. We're going to talk about typo squatting, and we're going to talk about the Sybil attack. 51% attack is pretty straightforward. The blockchain works on a voting system, right? Agreements between nodes, the ability for that agreement to result in an action. A 51% attack is when a miner or a mining pool, not a miner as an underage, as in a person who is mining for token, or a mining pool controls 51% of the computational power of the network and then creates fraudulent blocks of transactions for themselves, which then in turn invalidates things for other miners or other people using the blockchain. And in such case, either negating some transactions or reversing them, causing double spending, things like that, in sort of certainly losing credibility for the blockchain, but more importantly, preventing people from doing legitimate business or sometimes losing them extra money. This isn't going to be something where the controllers are necessarily stealing from anyone else or getting anything from it, but they do have the ability to earn more because they own most of the network and are blocking other people from doing it because their consensus is all that matters and no one else's does. Mitigations for this are proof and stake or proof of work, which essentially prevents these type of attacks by forcing people to have some of the cryptocurrency or prove that they're doing work to own pieces of the network. And it's very expensive for individuals or even mining pools to be able to do that, which actually is part of one of our other attacks too. So classic typo squatting, this kind of jumps back a little bit to the consumer side, but it's important to talk about when you're talking about blockchain too. It works well on cryptocurrency and blockchain because the domains coming online are new or more complex, and it's just another form of phishing. So really, the only way to protect against these sort of attacks is to actively stop phishing at the endpoint or to the blockchain creators themselves, whether that be through embedding through the application or something of that level. But it goes a little bit further than just the consumer because of the fact that this affects miners, it affects people who are actually building applications, it affects people who are trying to do legitimate things on the blockchain related to exchanging coins or launching ICOs. This is an attack that expands further beyond than just the consumers themselves. It actually expands into the people who are creating blockchain-related applications. But it does sort of teeter on that line of consumer and blockchain. The last attack we'll talk about is the Sybil attack. So if you're not familiar, it's a distributed denial of service attack where one person tries to take over a network by creating multiple false nodes. So attackers may be able to outvote the honest nodes on the network if they create enough fake identities. Then they can refuse to receive or transmit blocks, effectively blocking everything for other people. So it's not quite the same as a 51% attack, but this leads itself to be able to help an individual with a 51% attack. So in a really large scale Sybil attack, the attackers manage to control the majority of the network computing power or the hash rate, just like the 51% attack, except in this case, it's not for mining purposes, it's just simply to shut down whatever that application may be. And they can do it on a much smaller level, and instead of requiring the actual nodes that are required for a 51% attack. So if there's 100 computers, you need to have 51 on a 51% attack. In a Sybil attack, it's one person faking 51, and it works pretty well, except many blockchains use different consensus algorithms to help defend against Sybil attacks, which again goes back to the proof of work and proof of stake. So it's really, really highly expensive for one person to create a bunch of false identities if proof of stake is there. If you need to own 1,000 of the token in question for that blockchain, and even though they're fake, they have to own 1,000 of them, you create 51, you're now talking about that person owning 51,000 of that token. And that's a very expensive attack to go through if all you're trying to do is stop traffic and stop things from happening on that blockchain. As you can tell before I talk about this slide, it's a little limited. Blockchain attacks are actually pretty straightforward and pretty simple. Most of them focus on the consumer, and the blockchain itself seems secure. I say that in quotes. I say that tentatively. I don't say that with a lot of conviction because all it is a matter of time. We're all security folks. We know with enough time and with enough effort and enough money, anything can be hacked. So it's only a matter of time before the blockchain starts to see more and more attacks. which is why, in my personal opinion, we need to step ahead of it, not only to protect the blockchain, but also to protect the consumer before these things start to come to light further and larger and more adoption happens. Coinbase is a great example of a blockchain related company. I'm sure you've all heard of them. I already showed it on the one slide with the email. Has 50 million users. At this point, probably more like 55 million users. And that does not include any of the other cryptocurrency exchanges on the internet. So we're talking about a large group of people, probably people that work with you, probably the people who work for you or your user base. So it's important that we step ahead of this. So the remainder of my talk isn't just going to talk about what blockchain problems are presented, what the consumer faces, what that means for the future of security. I'm going to talk about, in my opinion, what we can do about it, the things that need to happen as us as a cybersecurity community, but also as the internet moves forward with cybersecurity. So we're going to talk about active protection against phishing and downloads and scams. We're going to talk about security that can be built into blockchain projects. We're going to talk about the on and off ramps for blockchain. We're going to talk about risk-based analysis for blockchain type security. And then lastly, my big hope for everyone, information sharing and exchange. And I hope it gets everyone very excited. If it doesn't, totally cool. Maybe I'm just too deep into this, but I hope it does. So what does active protection mean? Since all these blockchain or crypto-related attacks are novel and not been seen before, traditional methods of detection aren't going to work. You need to understand the context of the attack, the source, the purpose, and then be able to block it in real time. In order to do that, you essentially need to do this inside of the browser. If you're not familiar with why it needs to happen inside of the browser and the context I'm talking about, it's because agents and operating systems can't actually access the browser or even effectively protect it unless they're embedded into it and have the proper technique to detect those blockchain and crypto related attacks. So diving into that a little bit further, and what I mean about context, purpose, and source, if you're accessing a brand new attack that's never been seen before, first and foremost, it's not on threat intelligence. It's not on Phishing. It's not been reported before. It's a new attack with a new landscape, potentially with a brand new purpose. And these sort of attacks are highly targeted, as with all spear phishing. So you need to understand the context of the page. You can't just base it off of what the domain looks like or what's been previously reported. You need to know in real time, is this something that looks like something else? Is this something that has a purpose of stealing cryptocurrency? Is it trying to say, trade your Bitcoin for new token at a 0% trade rate? There's no fee, which is a really common attack. And what you're doing is sending it somewhere else. That's not going to come up as a regular phishing attack, but it absolutely is a phishing attack. And it absolutely has monetary damage. Long story short, the best way to do this is via a browser extension or a wallet that's based inside the browser. And then from there, you're able to actively protect against things as they come up. There's lots of different ways to do it. There's visual analysis that can happen, which is actually what we do. There's methods of detecting in real time with heuristics. There's methods of doing more active protection that is intrusive instead of more silent. And there's also ways of sort of warning the person before they interact with something with the sort of warning that you see on the screen here. This would actually occur in real time instead of waiting for someone to previously report it or previously find this and lose money. The next step is to bake security into projects themselves as they come onto the blockchain and into Web3. Much like Google Analytics, which is what I have basically presented here. Obviously, this is not cybersecurity. You guys already know how Google Analytics works. The ability to embed into security into an application with a line of code makes it much easier and much more digestible for someone who's building an application. So they can implement it in a way where it uses risk-based approaches or bad actor lists to prevent fraudulent use of their own application. It also can be used to incentivize security action inside the application, which as a whole, as we all know, there's very little incentive to do security actions inside of an application right now. So Gmail has a report spam button. How many people use it? To be clear, a lot, because a lot of people use Gmail. But proportionally, percentage-wise, it's much, much, much smaller than the entire user base of Gmail. And it's because people aren't incentivized to do security-related tasks inside their applications. So if we get security baked into projects where someone reporting an email or reporting a piece of a spam email, or I already mentioned that, or a scam or a phishing attack or reporting some fraudulent behavior or even reporting a bad actor gets them something. And in such case, leading down the yellow brick road here, you can already gather, we're talking blockchain, we're talking cryptocurrency, pay people to report things. Give them a fraction of a percent of a type of a token that's publicly traded on exchanges and indexes, and they will do your security actions for you because they're earning. So if we can get people to bake security into projects with a drop-in line of code that contains things like bad actor lists, risk-based approaches to what's going on inside the application, we can pre-block things before they happen, but also give people a reason to participate in security. Give people a reason to think ahead about what they're doing and say, I'm going to take an extra 30 seconds here to make sure what's about to happen is true and legitimate. And then when I do it, I'm going to earn 0.0001 of security bucks token, whatever it may be. And that's sort of a fundamental change in how we look at security. And hopefully, in my mind, a fundamental change how end users look at security. There's a learning curve, there's a gap for sure, but we got to start somewhere. Blockchain is the perfect place for that because it already has incentivization structures built into its core functionality. The next thing we're going to talk about is how people access the blockchain. And it varies. The who, what, why, where, when, how is all very important in understanding when someone is being attacked or being scammed on a blockchain application. We call those on and off ramps. How do they get on the blockchain? How do they get off the blockchain? Collection of that is difficult without access to the browser, as I mentioned 2 slides ago. So again, we go back to this idea that we need to be embedded where people are doing their activity, doing these actions. And when you're talking blockchain and crypto, you're talking about the browser. Once there's a method of identifying and collecting via the same active protection I mentioned, it can be used to map out attacks in a clickstream. Financial institutions currently use clickstreams to do fraud detection, fraud analysis, and then as well as research, but it has a perfectly good place in crypto and blockchain as well. They provide data that's really, really useful for behavior and usability analytics, which, as we all know, is telling us, how did someone come across this problem? How did someone actually get hacked? How do I do my incident response to find that sort of information out? The source and the purpose is all part of that. So when we talk about blockchain, talk about cryptocurrency, getting this information early in the sense of building it into things while new users are coming on board is critical to make sure we have an understanding of when they go on and off of the blockchain. It can be easily collected by the individuals running a browser-based security tool, whether that be a wallet or the extension. And all they need is an incentive. As I've already mentioned, kind of beat to death on the last slide, the incentivization is key here. We can collect data around where they're visiting, what they're submitting, completely anonymize it, break it into a million pieces like Zcash does with their sort of blockchain technology. Make sure it can't be tied back to Sally or Jim or Bob, but then pay them for sharing that information. They're sharing their threat intelligence, they're sharing the scams that they see, the things they come across, and we're also seeing how they interact with not just the Web 2 internet, but also the Web 3 internet. So when you can build into the browser, you can then see, okay, this is how we collect this data. Here's how we understand how these attacks works. And again, fundamentally change how the end user, whether that be in a company or a consumer, thinks about security. So they're more focused on what gets them secure, and in return makes us as cybersecurity professionals more well equipped to stop attacks, whether that be through info sharing or otherwise. One of the last things we'll talk about is risk analysis. So as Web3 progresses onward, we'll find applications use risk information. It could be for lending. It could be for insurance. It could be for mortgages. It could be for simply the use of an application like the future of whatever blockchain Facebook is, whatever Web3 Facebook looks like. It may not be Facebook. The idea here is you need to have risk information in order to be able to make those decisions. Well, how do you have risk information on something that's inherently private and inherently encrypted and inherently secure with like blockchain? The information can be used to prevent attacks before they occur. So it's very important that we gather some of that information. So with the right positioning, again, back into the browser, talking about that sort of beating it to death, but it's very important to understand that the browser is the OS these days when it comes to talking about this. You need to be able to understand how people are interacting with other people, with the applications in question, with the applications being built, with cryptocurrency wallets, and build a risk analysis based on their interaction. For example, very quick use case here. I'm going to go out for a $10,000 Bitcoin loan because I want to buy $10,000 worth of servers. I want to use it on DigitalOcean. The risk analysis on my profile would say, well, at some point, this wallet address sent out 2 Bitcoin to a scam address or a wallet that's been previously marked as malicious. We now have some real risk analysis information tied back to an individual user. But again, it's broken down to the point where it's either going to be double blind or invisible to people that shouldn't see it. So you need to have a company or a product or a conglomerate or a group of cybersecurity companies or people that believe in this be that trusted intermediary source. And in that, they also can become like a good source for know your customer, which is the idea that when you're doing analysis, sorry, not analysis, but when you're doing verification of a person, say they sign up to trade cryptocurrency on Coinbase, you need to hold up your ID to your face and take a photo with your webcam. It feels really, really intrusive and really, really painful, but it's pretty normal as it comes to know your customer. So when you're talking about that, the right company, double blind and trusted, becomes a know your customer partner, and it becomes a harboring place for risk analysis. And I don't mean a private company. I don't mean me. I mean, likely a group of cybersecurity people who create a blockchain application that is trusted and known and a good source for this, with no backdoors and complete transparency into how they interact. But the whole point of this is that we need to do some sort of risk analysis as we move forward while maintaining privacy and security in the process. Risk analysis beat to death in the Web2 web, in financial, fraud, etc. But when it comes to blockchain and Web3, it needs a new look and it needs a new approach. And this actually leads me to my last slide here. And then we'll obviously go into questions. This will actually take me a couple minutes. I'm really, really, really excited about this. It's not something that I'm saying I'm doing. This is something I want all of us to do. This is what I want the future of the web to be. The internet's changing. We're going from Web 2 to Web 3. In order to keep up, we have to stick together as a community, not just us here. Everyone at DEFCON, everyone at Black Hat, everyone at every company that just wants to make money in cybersecurity, we need to come together. Threat exchanges are currently focused on economics. Does it make me money? How does it help me? Does it give me an advantage over my competitor? And usually the answer is yeah. If I'm IBM, or if I'm CrowdStrike, or if I'm any sort of threat intelligence company, I'm selling it. I'm selling it to you. I'm licensing it to you because it's good for me and it's good for you. But I'm not sharing everything. I'm only going to share the stuff that makes the most sense to me. Only a few companies like Facebook and Google mainly have tried to tackle that problem, which is not open information sharing. They don't have major adoption because, again, the aforementioned monetary incentives don't exist. People don't want to share that information. We don't want to give away everything. We earned it in some sense. So you're leaving other people in the dark when you have cybersecurity information that may prevent the next colonial pipeline attack from actually succeeding. So Web3 is the opportunity and the time to change that. By creating a blockchain-based, confidential, and secure open threat exchange, the security community takes leaps ahead to begin sharing information to stop attacks and work together to make an open, industry-accepted platform. The reason why it has to be blockchain, has to be in quotes, my opinion, of course, is because the data can be kept securely. It can be voted upon when someone adds something. Do we agree that this threat information is real? Does the node agree? Does 51% of the network agree that this is something that should be added? Or is it potentially a bad actor that's trying to shove information in there? We have a consensus protocol. Everything can be made confidential and private, so you don't know that Verizon is sending threat intelligence to AT&T. AT&T is consuming it, Verizon's consuming it. They have this bilateral sharing, but they don't know where it's from. So they don't know that AT&T is giving up this information for them, and they don't know that they're sharing it back to AT&T. But the idea is they should be. They're in the same market. They're doing the same thing. Sharing that information should not be closed down. So This enables information sharing in an encrypted, validated, voted upon, and ultimately kept out of reach of bad actor method. Being able to put that out there, say it's confidential, say it's secure, say we all agree on it, and then share it back and forth while keeping bad actors or people that potentially shouldn't have that information out. And I have to jump back to sort of what we talked about with incentive structures. The cryptocurrency that could be used to incentivize cybersecurity behavior as a whole on the blockchain can power this application. So do you want data out of it? Are you going to consume a lot more than you give? Are you a company that mostly just sort of consumes data versus giving back? Then maybe the cryptocurrency is used to retrieve some of it. Conversely, that cryptocurrency or that token is then paid to people who send a lot of data back to the exchange. And it isn't to make the companies money. They're not going to care about a few dollars being transacted back and forth. What they're going to care about is the information that's being transacted. But that incentive structure allows people, again, if all of the big companies that you and I know are sharing threat information back and forth, and all of the consumers in the world who are using blockchain applications with that built-in cybersecurity incentive token, they're interacting together. It feels like a big community. Everyone's working together to improve cybersecurity, whether they're on the consumer end, reporting a spam, or just seeing spam. They don't even need to report it, just coming across it and having it be reported to a company, which is then reported to the exchange, or the consumer is reporting it directly to the exchange based on some sort of setup from an application that has it embedded. We as a cybersecurity community come together and create a new paradigm for threat information, for threat sharing, for getting things out there as quickly as possible when new threats come on board, which in my mind is the most important thing above endpoint detection, above spam detection, above phishing, above anything else, anything that I've ever built. This is way more important because it fundamentally changes security as a whole. And I think Web3 and blockchain enables that technology and enables us to come together to do that as a starting point. It has to be when something big and epochal happens, I believe it's the time. So on the last note there, a lot of the stuff I told you guys about was an opinion, right? And no, not everyone agrees with an opinion. So I'm happy to chat now about questions. I'm happy to accept hate mail. I'm happy to discuss my thoughts around things. Just to be clear, I'm not the know-all, be-all on blockchain and Web3. I do what I do and I know what I know, but I'm happy to discuss everything we talked about today. And thank you very much for your time.